Welcome to this explainer on the cosmic zoom out. Today, we're going to take a wild ride, starting right here on our familiar Earth, zooming way out into the terrifying abyss of deep space, and then looping all the way back to you. Let's get right into it. So let's start right in our own celestial backyard. What if the moon just crashed into Earth? I mean, picture it. You walk outside and the moon is just getting bigger and bigger, tumbling toward us at this terrifying speed. It sounds like a pure sci-fi movie trope, but let's break down exactly what would happen in this dramatic thought experiment. It would be absolutely apocalyptic. As the moon gets closer, the very first thing you'd notice is massive tidal shifts. We're talking coastal cities completely consumed by the oceans. Then, the moon's incoming gravity would throw all of our satellites totally out of orbit, which basically renders our modern tech useless. We're looking at relentless daily earthquakes and volcanic eruptions. But eventually, when the moon is just 11,000 miles away, Earth's gravity would literally tear it apart. The result? A surprisingly beautiful, shimmering ring system made of moon dust, kind of like Saturn's. Actually, scratch that whole crashing scenario, because in reality, the moon is doing the exact opposite. It's actively leaving us. It's drifting about 1.5 inches away from Earth every single year. And because of that, it's gradually slowing down Earth's rotation and naturally lengthening our days. Just think about this. 1.4 billion years ago, a day on Earth was only 18 hours long. Today, obviously it's 24, but a billion years in the future, a day is going to be 28 hours long. You could literally get a full night's sleep and still have 20 hours left over. Okay, let's step just outside Earth's atmosphere for a second. Think about a distance of, say, 100 meters. Back in 1984, astronaut Bruce McCandless was testing a revolutionary space jetpack. He floated exactly 100 meters away from the space shuttle with absolutely zero rope connecting him back to safety. Just a guy floating completely alone in the empty abyss. Now, the psychological reality of being out there? It's intense. McCandless later admitted that falling away wasn't really what terrified him. What truly unsettled him was how profoundly cold he got the absolute second he drifted away from the ship's protective environment. That insane combination of deep, freezing cold and deafening silence, that is the stark reality of the cosmos. Contrast that deep freeze with a wildly different extreme, 105 degrees Fahrenheit. This belongs to the story of Laika, the Soviet stray dog sent into space back in 1957. Scientists wanted to see if a living body could withstand zero gravity, so they strapped this poor street dog from Moscow into a tiny cabin no bigger than a washing machine. And instead of freezing, the temperature inside her capsule rocketed to a scorching 105 degrees. It was honestly a heartbreaking sacrifice for the space race. Sent up entirely against her will to test the physical limits of spaceflight, Laika was absolutely terrified. Sensors showed her heart rate literally tripled from fear during the launch. And tragically, because of that intense heat and stress, she passed away after just 6 hours in orbit. It's a really sobering reminder of the living toll it took to get humanity up to the stars. All right, let's move a bit further out into our solar neighborhood to a slightly more peaceful scene, Mars. If you were standing on the surface of the red planet, the sun would obviously look much smaller since it's farther away. But here's the cool part. Sunsets on Mars actually have this beautiful blue tinge to them. This happens because the superfine atmospheric dust on the Martian surface lets blue light penetrate just a bit more efficiently than other colors, giving the whole evening sky this really otherworldly glow. Mars is also, famously, the final resting place of NASA's Opportunity rover. This thing was incredibly resilient. It was originally only supposed to survive for 90 days, but it miraculously kept going, traveling over 28 miles across 14 years. But then, a massive, choking dust storm hit, totally blocking out the sun her solar panels desperately needed to survive. Her final, heartbreaking transmission back to Earth simply read, "My battery is low and it's getting dark." Heading even further out into the dark, back in 1977, NASA launched the twin Voyager space probes. And sure, they were out there to explore the outer planets, but they also carried Earth's ultimate time capsule, the Golden Record. This thing was designed to outlast humanity itself and introduce our story to the stars. It's packed with the sounds of nature, Earth's greatest music, spoken greetings in dozens of languages, and over 100 expertly curated images just to explain exactly who we were to anyone or anything that might find it. Fast forward to 1990. Voyager 1 is a staggering 4 billion miles away from home, and astronomer Carl Sagan convinces NASA to just turn the probe around for one last photo. It snapped the iconic pale blue dot picture, showing Earth caught in just a tiny scattered ray of light. It prompted Sagan to write this incredibly profound reflection. Look again at that dot. That's here. That's home. That's us. Zooming way, way out into interstellar space now, let's talk about Betelgeuse. This massive red giant is in its end stages, literally fusing carbon in its core right now. The explosion is coming, guys. In fact, it could go supernova within your lifetime. When it finally goes boom, it's going to explode so brilliantly you'll be able to see it during the day, and it will actually cast a shadow here on Earth at night. Thankfully, it's about 500 light years away, so it's safely outside the danger zone for us. So what happens when massive monsters like black holes finally collide out there? They create gravitational waves. These are literal ripples in the fabric of space-time itself, traveling outward at the speed of light. They stretch and squeeze absolutely everything in their path. Albert Einstein actually predicted they had to exist a long time ago, but it wasn't until 2015 that Earth's LIGO instrument finally detected these elusive ripples for the very first time. And speaking of black holes, they're probably the most elusive objects in the entire universe. Our galaxy alone might have over 100 million of them. Because they emit zero light, we usually can't see them at all, unless, of course, they're actively eating matter. What we can observe is the event horizon. That's the ultimate point of no return. It's the boundary where the gravitational pull gets so absurdly strong that absolutely nothing, not even light, can escape it. But here's the question. How do you actually photograph something that doesn't let light escape and is impossibly far away? Well, scientists realized that to capture an image of these things, they'd need a telescope the size of the entire Earth. Obviously, building a single physical dish that big is impossible, so they had to get really creative. They networked individual telescopes located all over the globe, syncing them up perfectly so they acted together as one massive Earth-sized lens. So this incredible planet-wide array targeted two specific supermassive black holes. On one hand, you've got Sagittarius A star, our closest supermassive neighbors, sitting in the center of the Milky Way, just 26,000 light-years away. On the other hand, M87, one of the most massive black holes we know of, located a mind-boggling 53 million light-years away. Defying basically all physical and mathematical odds, this array generated the very first real photographs of them, real pictures, not just simulations. But, even a behemoth like M87 totally pales in comparison to this next number. 100 billion. Deep in a galaxy 8.5 billion light-years away sits Phoenix A star. This black hole is 100 billion times larger than our sun. Just let that sink in for a second. It is so unimaginably huge that it's literally bigger than some entire galaxies. To really put that sheer, terrifying scale into perspective, the diameter of Phoenix A star's event horizon is 100 times the distance between our sun and Pluto. If you were in a spaceship traveling at the speed of light, the absolute speed limit of the universe, it would still take you 71 days just to complete one circle around it. And the scariest part? This cosmic giant is still actively growing. All right, after zooming out to those mind-bending, terrifying extremes of scale, let's snap right back to you. Take a deep breath. You are deeply, literally, connected to the cosmos. Every single breath of air you just took contains elements that were actually forged in the superheated heart of a dying star billions of years ago. So, I want to leave you with this final thought. Is humanity simply the universe getting to observe itself? I mean, knowing that every single glass of water you drink traces straight back to the Big Bang and that the atoms in your body are quite literally made of stardust, doesn't it completely change how you see your place in this vast, chaotic, and unimaginably beautiful cosmos? Thank you for joining me on this explainer. Keep looking up and keep wondering.